All right, recording is on. So now I'm going to share my screen back to my board. And here we go, 2.1. And y'all, this deals with graphs of equations. All right, so I'm just making sure I'm keeping that in line for y'all. So I'm going to start graphing some different. Some will be lines, some will be parabolas, the V shapes, and some of that, okay? And also for my number one, I'm going to graph y equals 4/3 x minus 2. So the table method, I'll show you what I'm going to do to this. I'm just going to come in here and make me a little x and y table. And I'm going to tell y'all a trick. When I'm graphing, whatever exponent is the highest one by the x is, I pick one more point in that. So if there's not an exponent shown by the x, it's automatically a. So that means I need 2 points. If that was an x squared graph, I'm going to need 3 points. For the x cubed graph, I'm going to need 4. Okay. So I'll let y'all help me pick these numbers here, see how good y'all are at these. One number I will pick 100%. The easiest number in the world to multiply. Oh, there's one easier than that. 0. Because 0 can multiply by a fraction and knock it out too, right? For 1, if I multiply, I still got the fraction. So, who's going to give him a second number?
4.
Oh, go one less.
Okay,
3. I think 3. And I'm telling you, I'm basing it because of this fraction. If I put a 3 here, I can cancel that fraction out. If I put a 6 here, 6 will divide by 3, making that a 2. But if you put a 1 here, 1 times 4/3 is 4/3 still. So then you got to try to add a 4/3 minus 2. And to do that, you have to find a common denominator. So you're going to give yourself a lot more work. So when you got fractions, make those x's multiples of that denominator. So if I put a 0 here, 0 times 4/3 is, and then 0 minus 2, -2. Okay. Now I actually put it up here with the 3 because I want y'all to see that. So if I use the 3, I can just cancel them out, kind of. And really, that's 3 divided by 3 is a 1. But when you multiply 1 times 4, you still got a 4. So it's basically going to be what, a 4 minus 2. And that'll give me a 2. Now, remember, I only needed 2 points, but let me show you. I could have put a 6 there. You gotta be careful. If you use a 6 instead of the actual 3, when you divide the 6 by the 3, you're going to put a 2 there. So now remember, these get multiplied now, right? Then you'll be 4 times 2 be what? 8 minus your 2 would be a 6. But still, even if you got to do that, that's a lot easier than trying to find common denominators. And then trying to figure out, okay, I'm multiplying this fraction into top times top. But a lot of y'all start doing that cross multiplying stuff, and you can only do that on equations. You can cross cancel, but you can't cross multiply like that. Does that make sense? All right, so I try to keep my numbers small too, so my graph can be small. Now, if I put big numbers here, I'm not going to be drawing this graph out of ways, okay? So I can go up about 5 or 6. So now remember, the way I graph this, each one of these rows is a ordered pair, right? I can plot 0, -2, and then I'm gonna come back and plot my 3, 2. And if you wanted to check accuracy, that third point better be in that straight line with it, okay? So remember, X, Y. X can only go left and right, the Y can only go up and down. So when the X is 0, you're gonna be on this line somewhere, because the 0 don't go left or right, right? And then I would go down 2, I would start at my 0 and go down 2. So my first point is definitely on the Y-axis. Then that's y-intercept when you look at it in this form. Y equals mx plus b. Remember that b is your y-intercept where it's crossing that y-axis. My next point I'm going to put is 3, 2. So starting at the middle, 3 goes right 3 and then up 2. You know what used to make me good at this stuff? Y'all wouldn't believe it, but balance sheet. When I was young, we had balance sheet, we had to move the pegs. A5, B3. If you didn't know how to do it, you didn't think nothing, okay? All right, 2 points is all you need. You know, draw points, okay? So that should be hopefully bringing back memories. Now, let me show you one. It's pretty much the same, but more difficult. How about if I started out with 8y plus 4x equals 4. Now, you can still set up the x and y table using that, but what I'm going to show you how to do is solve that for the y. If we solve it for the y, then you can use them powerful PA83, PA84 calculators. Okay? And you need to have to do this anyway like this. So I'm solving this for the y. What we gonna do first? Subtract 4x. Subtract that 4x. So you're gonna bring down that 8y. 4x, -4x, they cancel on that side. So can he add them together? No. Good job. Not like terms. So you got 2 options here. You can make that 4 minus 4x, or if you want it in the form of the y equals mx plus b, you can do the -4x plus the 4. I usually keep mine like that, and I'm just going to come down and do that good, okay? Which on either way would work. You can do the 4 minus 4x and it still work. So, one more step. I want the 8y to be a 1y.
So you divide everything by 8. Right?
Divide everybody by 8. So remember, multiplication and division, they got to distribute over everything. So you'll divide everybody by 8. Now give me a 1y. -4 over 8 will reduce. Next one give me what? A negative 1/2 x. Now let me tell y'all a trick. If you don't know how to reduce them fractions good, you're about to have a powerful calculator in your hands. The PA83, PA84, punch in -4 divided by 8 on the calculator. It's going to give you a decimal. But if you hit math and enter twice, it'll give you the reduced fraction. Okay? Which means I know what the 4 over 8 is going to reduce to. A positive 1/2. Okay? Now, when you're online doing this one on Math Lab, it's going to break it instead of going by ones, it's going to go by halves. because they got tabs in. So usually, if it's got a 2 on the bottom, it's going to break each unit into 2 parts. So this one goes 1/2, 1, 1.5, 2, 2.5, 3 on the scale. Okay. Okay, there's 2 numbers. I'd probably pick on that one if I was graphing this one. Now, notice you got ugly fractions no matter what. Because of that 1/2 at the end being a positive 1/2, no matter what you get on the first part, you're adding a fraction to it. So you can't bust them like you did over here. But I can make them really easy. What's the first X I would use definitely?
The first what?
The first X value.
Oh, I would do 2.
Well, give me the other one. Well, go, you said it every time I'm going to use.
Yeah.
Now, watch this. 0 times negative 1/2 is 0. 0 plus 1/2 is 1/2. And I'll tell you a trick on the next one. I know on this one, since I had a fraction and the whole number at the end, I got rid of the fraction. But let me ask you on one. What if I made that a 1? What is 1 times negative 1/2? And then add that to a positive 1/2, you get a big O. So I just want to make it a 1 this time. That's one of the few times I violate. It's just because you got another fraction here, okay? But I did know that if I had a negative 1/2 and I added it to a positive 1/2, I can make that a 0. So that's why I used a 1 on that one, okay? I'm not going to kill you on test with fractions. Now, same thing on this one. When you graph this one, the math lab is going to make marks in between each of those for the halves. Okay? So like on this one, 0, 1/2, I'll be at 0, and then I'll go up 1/2. Okay? And then my 1, 0, I love that because that's right on this x-axis, that's 1. And then that line would go down here. Now, I'll do a quick check. That's the slope of this line, right? 4/3. That's the M, the slope. That's a positive number though, right? 4 divided by 3 is positive. So your graph has to go uphill. This, when I solved it, gave me a negative 1/2. That's a negative slope, which means my line better go down here. Okay? So just do a quick look you can do there. Or you just plug them into that y equals on the calculator, it'll spit out the graph. And I'll show you how to use the second graph to get the table. And on the table, you'll have all the values that you can use on the math lab. So I'll definitely be sending you all that one tonight for a video. All right, go graph parabolas.
I have a question.
Yes.
Do you have a picture or something of the best calculator that we should get?
The calculator y'all need?
Yeah. The best one?
Y'all need a TI-83 or a TI-84. Those are from Texas Instruments. I'm gonna write that right here.
Thank you.
So TI-83s are pretty old. But the TI-84 can be a TI-84 Silver Edition, TI-84 Plus, TI-84 CE, which is probably what you got, which is color enhanced. That's what that CE does. You get color graphs. The CEs, oh, what's that other one called? The little fancy one that you can switch them out. I forget what it is, but TI-83, TI-84, okay? And the TI-84 would have more power than the TI-83 as far as memory. But you need one of those calculators for my programs to be able to go into your calculators. Okay, and I'm going to be feeding y'all some calculators later for the quadratic formula, factoring, synthetic division, Kramer's rule, all kinds of stuff. Okay, and that's just to help y'all later on. Now I'm going to show y'all quadratic formula by hand in here. But when we get to the next chapter, do we want to keep doing the quadratic formula by hand? And we can spit it on the calculator and knock it out quick. Some of y'all like doing them by hand, I ain't gonna lie. I probably did too back in the day. Or up to check yourself. How about that? You do them by hand and then check yourself.
Yeah.
There you go. The thing that gets people on the quadratic formula is simplifying that radical. That square root of b squared minus 4ac stuff, you know. All right, so did that answer y'all's question online? Okay.
Yes, thank you.
All right, y'all, so we're going to graph a parabola. So y equals -2 x squared. Now, I'm going to be picky on these points. Oh, I could also be putting something else in instead of lines here, couldn't I? Have y'all ever seen them like this? F of x is a y in the real world, okay? So some of y'all graphs could be, they'll put both symbolisms in this one, okay? But just remember, those are the same. This is just more better for shorthand. And I can say, hey, find me f of 2, instead of saying, hey, find me the value of y, and you put a 2 in for the x. So that's mainly just shorthand type stuff. When you graph the x squared graph, the 3 points you will pick are -1, 0, and 1. Now, you don't have to have -1 here and +1. You can do -2, 1, -3, whatever numbers you want, but you better have the 0 in the middle. And when you graph these on MATLAB, this is the first point you're going to put. Okay, so these graphs are going to look like a U. And it'll have 3 dots on it, which means you need 3 points. But on the parabolas, which what we call this, you got to start with that bottom point or the top point, which is called the vertex. And later in life, I'll go through all that vertex stuff with you. Main thing, middle point better be a 0. So, I'm going to put a -1 in, and then I'll come over here and put a 0 in. And then I'll come over and put a 1 in. What are these for? So this is the shape what we call a parabola. Parabola. I don't know, I'm from the South. I might talk funny on it. I don't know. Parabola, parabola, I don't know. So, what am I doing to that in first? I got -2, -1 squared.
I got -2.
For your final answer?
I believe so, sir.
Oh, you did good if you said -2.
Cool.
Because remember, order of operations says exponent number 4, any multiplying, right? So you cannot multiply first, you better use this exponent, and it applies to what was in those parentheses. So I'm squaring -1, what's going to give me? And really, anytime you square a negative, you're going to get a positive, like you said, okay? And then -2 times 1 is -2. So online was correct. Well, the middle one's going to be really easy. 0 squared, and then that times -2 is a big O. And then when I put a 1 in, so what y'all getting when I put the 1 in?
I got -2 again.
But it's still gonna give the same thing, right? -2 times the 1, which is. So y'all will notice that the parabola has what we call a little symmetry to it. My vertex point is 0, 0, and then on both sides, my -1 or my +1, both give me values of -2. If I put -2s in here, +2s, I will still get the same numbers. They're going to be symmetric all the way through, okay? But then again, if you put a 2 on that, you better draw this out to 8 already. Because 2 squared would be 4, right? And 4 times 2 would be 8. If you use a 3, check it out. 3 times 3 is 9 times 2. So if you wanted to put 3s, you draw this out to an 18 on both sides. I gotta get y'all trained on small numbers. All right, let's see. I'm all going down at this point. So negative, now let me show you on MathLab how you're going to draw this. You're going to pick the little pool that looks like this. The first point you got to plot is that middle. And actually on all y'all's graphs, it'll be on here. Some might be shifted up or shifted down if they add numbers at the end, but they're all going to center right off that y-axis, okay? And then you come over here, you'll do -1, -2. At that point, MathLab has a straight line. But when I come over here and go to 1, -2, at that point it turns it into a parabola, okay? So that thing will come down. And graphs look a lot better on graph paper. Or MathLab makes them look pretty good today. You got the 5 units right. So y'all got questions on that? So let me tell you this. This x squared term, if this number is positive, that thing's going to look like a U. Anytime that first number is negative on the x squared, it's going to be a upside down U, okay? So this is if you got negative x squareds. This would be if you had positive.
So if you know it's a parabola, why would you plot 3 points?
Oh, it's because MathLab one way it's going to do it. You basically, on these graphs, you got to do this and then jump on both sides. But yeah, by hand, if you know that, hey, I'm symmetric, here's my point value. We'll draw this side, just like it, right? But yeah, it's just because it's MathLab. And so that's why I'm trying to show you all these tools here, because these are showing you how many dots you need for these, okay? Oh, next one. See what's on. Okay, who am I gonna pick it? So this one has, well, I'm not gonna say because I don't want to give it away. So what's that bars mean? Oh, I heard that absolute value, right? So think about absolute value. It's got the same priority as parentheses on the order of operations, which means that's the first thing you do, then you jump outside of them, okay? But remember, absolute value is just distance. Distance. If you live 5 miles from somebody, for them to go to your house is 5 miles, but for you to go to their house is also. So the direction didn't matter. We're just looking at the distance, right? So on a number line, who's further from 0, 2 or -2? They're the same, ain't they? So both of them would have an absolute value of 2 because they're 2 units from the 0. So when you jump out of them bars, your sign better be positive, right? But I don't go, well, I'll live -5 miles from my friend. Right? Now, on this graph right here, y'all. It's gonna make a V, and it has 2 points. Although it's got 3 sides, this one, they're nice. And once you put that vertex and go to one side, it automatically jumps over and does the other side for you. They're not so nice on the parabola. You physically got to get all 3 points on this one, okay? Now, your vertex point has to be whatever number makes this thing equal 0 on the inside. So if you got a positive 2 in there, what's going to make that equal 0? Negative 2. So I'm going to do negative 2 because you got to get it to where it's at that 0 value, okay? So let's see, if you put a negative 2 in there, what's that going to get? Well, inside I can do the work. Negative 2 plus 2, we said was 0. That's what value 0 is. 0. So this has to be the first point to plot. When one with the y value equal to 0, okay? Now, any other point you want me to give? Since that's a negative 2, I can put a 0 here is really easy. Or you could have did a negative 1, a 0, anything. You could went the other way and did a negative 3. It didn't matter. So I'm just going to use a 0 because that looks easy. So you put a 0 in there. 0 plus 2 is 2. What's that do, value?
2.
So now we got 2 easy points. So when Math Lab, when we do this one, you got to start with the one with the y value 0. Okay. So at that point, I would come over here to negative 2, 0. Whatever point lands on that x-axis is the one you're plotting first, right? So then my second point was 0, 2. So here's 0 on the x's, and I go up 2. So when y'all put that point, it's automatically going to mirror the other direction. So I've never figured out why they made me do 3 on this one and 2 on that one. Now, I will say this. Later on in the course, when we get to chapter 8 stuff and you're doing so many quadratic formulas, they actually at that point let me use 2 points on this. So there must be a reason. I think they're maybe wanting y'all to see all this symmetry type stuff maybe. And how when you square numbers, they're both positive, the negatives are positive and the positives become positive when you square them. Watch my video on the calculator because absolute value, hit the math button on that calculator. On the left side. Get math? Arrow right once on highlight number. What's the first thing it says? ABS, which is absolute value. You find it back there?
I get math into it.
Arrow over until the highlight on the top says number.
Okay.
NUM, and the first thing you should see is ABS. So if you're graphing, you want to hit that to get your absolute value to put them bars on there for you. Okay? Now, I will say the older calculators, when you do the ABS, it'll pull up the ABS in a parenthesis. On this one, you would put your x plus 2 in parentheses and shove it. The newer calculators, it puts the actual absolute bars there for you. Okay? What yours is definitely going to do for this is CE. And I really think this one was being nice because remember the exponent on this x is a, and I needed 2 points. So go figure that out, right? All right, y'all, here goes. Y equals X to the third plus 2. So guess how many points MATLAB wants? 4. They got what, 3 plus 1? So we don't have a tool that looks like a squiggle, but that thing will have about 4 dots on it, okay? And I ain't got no trick to these ones other than I'll keep my numbers small. Because when you cube something, you're going to find that times itself 3 times. And 3 times 3 times 3 is already 27. That's too big. I don't want to go that far on these graphs, okay? So initially, I'd probably use a 0, a 1, kind of a -1, and then probably a 2. And 2 is going to make me a little big, but it don't fit on my graph. So if you put a 0 in there, 0 to the third power is still, and then 0 plus 2, and it's going to give me a 2. Oh, I think I hit my table a little bit. There, y'all see that better now? Well, what's 1 to the third power? And then 1 plus 2. -1 to the third power. -1. And then -1 plus 2. So remember, unlike signs, subtract and get the sign of the bigger number. And then 2 to the third.
I got a 10.
Oh, you didn't say the final answer, didn't you? What did you just say?
10.
10. Because 2 to the third was 2 times 2 times 2 is 8. And then 8 plus 2 is definitely 10. So that would have been a big enough number for me, that 10, right? Might have been a little smaller if I'd used a -2, because that would have given me what, a -8 plus 2. Would have made it what, a -6 or so. Now, I'll tell you, when you're plotting these points, it looks crazy until you put that last point, then MATLAB draws a pretty curve for it. But until you get to that, it's crazy. All right, y'all, so let's say I got a 0, 2, a 1, 3, a -1, 1, and then a 2, 10. So let's see, 2, 10, 2. So I'll tell you, MATLAB will draw this for you, but this one's probably going to come up to here. It's going to curve and then curve back up, okay? But y'all, you don't have to, as long as you put any 4 points on that, if they're correct, that last point you put is going to draw the curve for you, okay? Or throw them on the calculator. Now, if I'm doing this one on the calculator, since that's a cube, I'll do my y1 equals x. And then to do exponents on the right side, you'll see what we call a period. Looks like an upside down V. And then you'll put your 3, and then come in and do the plus 2. Just remember, newer calculators, when you put that 3 in, it's going to be up there like an exponent. You got to arrow it back down to put in the plus 2, okay?
Is that how we would do that in the calculator or a math lab?
Oh, this is what I'll do in the calculator.
Okay.
If I was going to graph it on my calculator,
So how do we find the little upside down piece?
That'd be on the right side, right under that clear button. Look on there and see. Under them 4 little arrows. Bang, go down, go down, like that.
Okay, that's what that.
Mhm.
All
That's what that's for.
right. Okay.
I'm gonna show you all kinds of hidden things on that calculator by the time the year is over. I actually made a video for my final using the calculator. What did I say? There's 25 questions. Out of 25, I think I could knock out 18 on the calculator without even doing any work. As long as you know how to use that. Especially on the graphing part. Y'all would not believe how much you can get out of graphing stuff. Like you can't factor, graph it, look for the x-intercept. You can't solve equations, graph it, look for the x-intercepts.
So we need to hurry up and get a calculator.
Go get a calculator. Someone said, what, Walmart or something that my other class was not too bad. Textbook brokers and stuff, probably 60 to 70. Pawn shops, how much are they running there? I can't tell them what, about 50 to 60, 70 maybe? Only thing, just turn them on, make sure your screens work good. But yeah, Walmart, they're jumping up about 120, 130 maybe. But you got the color enhanced CE, so.
Yeah.
So if you want to learn it, you take a calculator and you give it a fill in your bid right by you, you know, and dress it up in pretty, what do you call otter boxes and all that fancy stuff.
You need games on it too.
Oh yeah. They hold a little memory on them games, but yeah. I seen, what was it, Texas? Someone had on there, Texas or something like
Yeah,
that.
Brick, Tetris. I used to play a lot of it.
Yeah. Yeah. Those calculators got a lot of power. Used to be able to compete with, y'all ever heard of Hewlett Packard? Hewlett Packard. They're in the computers now and thing, but they used to make calculators when I was younger, and there's a longer looking version. But there was too much issues with, they're not what we call what, user friendly, maybe. All right, so that pretty much takes care of those. So next class, I'm going to be doing a little bit of domain and range. Right? Y'all remember that stuff? Let me see what else is here. Yeah, we'll do domain and range. We'll mess with that S notation. I'll tell you about f of x. And I'll give you like f of x equals 3x plus 2, and I'll say find me f of 2. So that means you're going to put a 2 in for all the x's and solve it. Okay? And then a little more graphing. And I even show y'all, ever heard of the vertical line test? So if I run a vertical line on these graphs to tell whether they're functions or not, see how that's only, well, if this graph was drawn correctly, I'd only be intersecting the graph once with this vertical line, which means it would be a function. Let's say I had some kind of graph that came around like that. And the vertical line hits it on top and the bottom, so that would not be a function. That's all that is. That's not bad, was it? All right, let me think which block am I looking at now. 116. So a little earlier, y'all ready?
I have one more quick question. Okay, you know, like when we did 3 points, there was considered a parabola.
The curvy U.
Yeah.
Uh-huh.
And then when we did the B.
Mm-hmm. It only needed 2 points technically.
Right. So, oh, that'd be powerful.
A B.
Okay.
Leave it out. Nothing fancy for those.
Okay.
I guess if I was going to call it anything, I would say maybe that's the graph of a cubic graph that does the
Okay.
cubic. So
I was scared with you. There's a rainbow like all over it.
I don't know why something hit that dude in the head when he's sitting there at that apple tree that day. I said, damn, parameter, that sounds like a good word. And remember, because he was drawing the line, he said, well, I throw it up, it went up, but then it came back down, so what it made?
Rainbow.
Well, rainbow, like a parameter, right? Stretched out a little bit, but. So here's the question, anyone doing the lab today? No, because we don't really have nothing to do over there in support lab, so all y'all need to do today for sure is do the support agreement quiz. But I don't want y'all forgetting that and getting dropped. They drop people out there without warning y'all sometimes, okay? So you just gotta watch it. Now, I will say this for everybody. Have y'all all set up your payment plans? If you don't set them payment plans up, guess what? They will drop y'all out. So y'all got to get them done. I can pull a list later and see who's not done that. But all you got to do is just go in there and tell them, oh, I'll pay blah, blah, blah. Some of y'all might have financial aid that got messed up and need that taken care of. So just make sure y'all don't have no old emails coming from financial aid or something saying that y'all are going to get dropped if you don't get a payment plan, okay? All righty, y'all. Anyone online questions? I'm gonna pull y'all back. So, what was
I have a question. I'm sorry.
Okay.
So I'm so confused about like quizzes. Do we log on to do that? Or tests? How do we, or do we just do them as the
So you're going to go into where I said, remember, go into that math lab assignments.
so we just do them as we go, as they're due? Okay.
Now listen, y'all are not going to have quizzes every day. The only quizzes I got for y'all are test review quizzes. And that's just to make y'all do good before y'all do my test. So I got review quizzes set up before each one of my 4 tests. They're the quizzes. So you do them as many times as you want to.
Okay.
Get a good grade on that quiz. Because if you can get a 90 on that quiz, you're going to make a 90 on my test. It is definitely practice because the quiz and the test are the same things. Okay? 20 questions on this will be the same 20 on my test. Other than them numbers will be different. And they might put X's and Y's and stuff. It's going to generate different numbers, but it's going to be the same questions. So if you get good on them and you knock them out on that, every time I have people that does those quizzes more than once or twice, I've had people do them 30 times probably. But by God, they pass that test. Okay. I guess once in a while you start learning by repetition or whatever you call it, you know.
So like everything will be due like Sunday night.
Yeah, I got everything due for Sunday nights at midnight. Now, I'm going to be adjusted this week because when our chair set up the schedule for me, she didn't account for Monday being a holiday. So I think this week is showing 2 assignments due. The only thing y'all got to do this week is 2.1. Okay? Now, support people will have a support 2.1, which will talk about how to plot points and stuff. And what I do usually, after I give y'all an assignment like support or something, if y'all have trouble on that, my next class in support lab, I'll fix y'all on all that. Plus, I got support videos out there. So you'll have your college homework lecture videos, we'll say homework lecture videos. On the left side, right below that, a few notches, a few links below, it says support lecture videos. Support lecture videos only does support stuff. Okay. So I'll probably send out videos tonight, especially on the calculator. Oh, before we leave, who needs a calculator? Let me put the formulas in it real quick. It takes me about 5 seconds. These are outlaw programs. If you ever set a calculator to someone at UCA or Euler, charge a lot of money. Because the programs I'm giving y'all had the power to factor. And there ain't many calculators on this program that got factors. Oh, y'all know y'all got a calculator over here? Okay, so you're gonna get it. Oh, let's go get my mail little thing. Oh, yeah, you can. And I will see y'all when we come back Monday. Monday. Y'all got me on Friday. I'll be here on Fridays from 10 to 11. Same room if y'all want.
So you said we come back on Friday?
Now, y'all online, when
Yes,
y'all come in here next week, bring your calculator with you so I can put my programs in it. It makes life a lot easier when we start doing the quad formula stuff. All right, so I'll explain it when we get them, but everything I just put in is running.
what room number are you in, Mr. Rathon?
Hold on, I couldn't hear you. Okay, say again.
What room number are you in for us that's coming on Monday?
Yeah,
The room number that you're in?
it's in BTC, which is right next to the IT building, sort of put part of it.
Okay,
And I'm in 339.
339, okay.
All right, y'all, so I'm gonna cut my recording and I'll send this out later and see how we did on it.
Thank you.
All right, y'all online, I will see y'all Monday. Y'all have a good weekend.
You too.
So let me see how many are coming Monday, and if some of y'all need to come on up. She wants one? So you're coming, okay. Now, next Wednesday, will you be coming also, or just gonna come Monday on? Okay, that'll work.
I mean,
Well,
the
this is
option
first
to come
time.
in,
Y'all
the
ain't
option-
looking at emails enough yet?
So we don't have to come both days.
No, you just come one day if you want to. If you feel weak and you really need to come both days, you come up here both days.
so we can come both days, even though I just, okay, never mind.
Something like a couple of years ago, I was out trying to be a vice president employers and wrong for Congress today.
So you do that. So when I start talking about programs, we get them all right here, program days, and they're all right here. So just want to see one. That's one we use out a lot. So when I do quad, you'll hit enter. AD still be the numbers. So like I had a 1, say a 6, and then -7. That probably won't get it. Well, I did factor into a 1 and -7 was my solution. And then I got quick. It'll even do the one with the. I want the fourth load. Right.
So question, you know, we get ready to do our exams and stuff, because I know, well, my algebra teacher, we had to show our work. But if you're saying that we can use our calculator, which I don't mind.
Yeah, there's, I mean,
Cause I would, you know,
the only work I'm gonna maybe, if I require any work, would be if I specify on the test page. Like we'll do, later in life, we'll do like systems of 3 equations. And I'm not gonna try to do work on one of those, y'all can see me, but not the whole thing.
okay, so.
And I've never really even requested that yet,
Oh,
so you're probably good to go.
okay, so we just do our homework and, great.
I mean, because the calculators are cool in here.
And then,
And
that was.
Like I said, there was 18 questions I could do on final with that, without even touching the pieces.
And that's,
You know what I
I
mean?
actually did so well on all my homework assignments, but when she wanted to work everything out, it slowed me up on some of our tests. And I was like, well,